Hello students, welcome to lecture 11 of polynomials. This is the lecture on remainder theorem only. Okay, we will learn about the divisor and the remainder today. Now we know that p of alpha is the remainder when p of x is divided by, we know that p of alpha is the remainder when p of x is divided by x minus alpha. Got it? This is the simplest way. Now, let us see that if divisor g of x is given to us, okay, that is x minus alpha, then what will be the remainder r? That is what should be the remainder r. Okay, we will go through it. Now, if I say that their polynomial this p of x is divided by g of x. Now if p of x is divided by x plus a, first if I say x plus alpha, okay, then what will be the remainder? See, I can write that x plus alpha, because it is a linear equation, I will write x plus alpha is equal to 0, hence x is nothing but equal to minus alpha. Now because x is minus alpha, p of x will be what? Which is the polynomial we are dividing? P of x. So in place of x I will write p of minus alpha. So the remainder will be p of minus alpha. Okay, the same thing. Second condition, that is what is gx? That is if p of x is divided by ax minus b. That is a linear equation of form ax minus b. I can say 5x minus 3, 4x minus 2 like that. Then I will do the same thing. Ax minus b is equal to 0. So ax is equal to b. So x is equal to b upon a. Now putting this x is equal to b upon a, we know that the remainder theorem, correct? The p of alpha, that is whatever the value of alpha is, that p of alpha is the remainder. So p of b upon a is the remainder. Why? Because in remainder theorem it is said that when p of x is divided by x minus alpha, then p of alpha is the remainder. Correct? Got it now? Can you understand? These are the general forms of the divisors given. That is x plus alpha means, sorry, x plus 2, x plus 3, it can be anything. If x plus 2 is there, the remainder will be x plus 2 is equal to 0, x is equal to minus 2, so p of minus 2, like that. Now, the third thing, that if polynomial p of x is divided by ax plus b, then what will be the remainder? Again the same thing, ax plus b is equal to 0, so ax is equal to minus b, so x is equal to minus b upon a. Correct? So the remainder will be p of minus b upon a. Got it? Now the fourth condition, that is if a polynomial is divided by b minus ax. Okay, then what we'll do? B minus ax is equal to 0. B is equal to ax. So b upon a is equal to x. So we know that remainder is p of alpha. So here it will be p of b by a is the remainder. Got it? So this is the thing which you should know. Now, see, I can say, sorry, first condition if I say x minus 2 is there, okay? If the polynomial is divided by x minus 2, then I will take x minus 2 is equal to 0, x is equal to 2. My remainder will be p of 2. Second condition if I take, from here, that is ax minus b. Let us take 5x minus 3. So if I take 5x minus 3 is equal to 0, 5x is equal to 3, so x is equal to 3 upon 5. I am getting the value of x, that is 3 upon 5, and p of alpha. So I will write p is 3 upon 5. So now third. Okay, third is ax plus b. Now see, ax plus b. Same if I take 5x plus 3. I will write 5x plus 3 is equal to 0. Then x is equal to minus 3. So x is equal to minus 3 by 5. So my remainder will be p of minus 3 by 5. Got it? These are just an examples of the above conditions. Okay? Don't mix it. Got it? This way you have to do the remainder theorem, which is very easy. Don't make it complex. Okay? So these were the different conditions which you should know. Now let us take one example of the remainder theorem, which is very easy. Let us take one example. Let me say that p of x is nothing but x square minus 3x plus 2. Okay? And we divide it by x minus 1. Okay? Very simple. According to the theorem, if I say x minus 1 is equal to 0, then x is equal to 1. Okay? Now putting x is equal to 1 in p of x, what do we get? See, we get p of x is equal to x square minus 3x plus 2. So, p of 1 is equal to 1 the whole square minus 3 into 1 plus 2, that is 1 minus 3 plus 2. So, it is equal to minus 2 plus 2, which is equal to 0. Okay. So, p of 1 is nothing but 0. Correct? You got it now? According to the remainder theorem? Yes. So, I can say that x minus 1 is the factor. Now, I can say that x minus 1 is the factor of the polynomial p of x. Correct? This way we do. Now let me check it. Let me do a remainder theorem like this also, that x square minus 3x plus 2 and x, it is divided by x minus 1. We know that first step is nothing but let us divide this first term with this first term, x square upon x. 1x gone, so x. The first term of the quotient will be x. X into x is x square. X into minus 1 is minus x. Change the sign. Let this go. Minus 3x plus x is minus 2x plus 2. Got it? Now, same thing. First term, that is minus 2x, let us divide it by x to get the second term of the quotient. So it is nothing but minus 2. Okay. Second term is minus 2. So minus 2 multiply with x, we get minus 2x, and minus 2 multiply with 1. We will get plus 2. Minus minus is plus. Now change the sign. So the remainder is 0. Okay. Now, according to the theorem, how will I write? I will write x minus 1 into x minus 2 plus 0. So I can write x minus 1 into x minus 2. We can write these two, x minus 1 and x minus 2 are the factors of the polynomial P of x. Got it? This is the remainder theorem. This is nothing but the remainder theorem. Now, in the next lecture, we'll do more sums. I end my lecture over here. Thank you very much.